Hi there. All right, we're going to be solving today a non-erodible channel problem. So, look in your packet, you're going to find a problem that looks similar to this. This is going to be finding whether the velocity of the channel is going to scour away the sands on the side. So to do scour velocity, first we have to figure out what velocity our channel is currently conveying. So to do that, we're going to have to use Manning's equation. And to use Manning's equation, we have to work through the process. We're going to start with getting the perimeter. Perimeter of a trapezoid is given in your hydraulic notes. It's going to be V. All right. We have this equation. We know the base, 10. I'm sorry, 20. This is given in the problem. We know our y height, which is also given in the problem, is 10 feet. And then for our z value, we're going to have to figure out, we're going to have to look at a table to see what the proper side slope is for a sandy channel. So if you look at if you look at your table, you're going to find z for a sandy channel is going to be 1 to 2. So our z value is 2. All right. So you're going to go through and you're going to calculate this, and you're going to get a value of 62.74 feet. All right, first step, we have our perimeter. Now we need to find our area. So we're going to go to our area equation, also given in most hydraulic handbooks. All right, this is also pretty straightforward. We have our base, we know our y height, and as given in the last problem, we know our z. So we're just going to plug in our values, and we're going to get a value of 6. All right, 400 feet squared. So the next step in our problem, we're going to put these two values together and find our hydraulic radius. So hydraulic radius, as you might know, is going to be the area divided by the perimeter. So just take these two values and simply divide them. Just run that through a calculator, you're going to get a hydraulic radius of 6.18 feet. Awesome. All right, so now we have our hydraulic radius. We need to go back to the Manning's equation to find what our velocities need. So record these values in whatever notebook you're working on. I'll erase this quick. All right, so we know. So the next step is to, we have to find our Manning's constant now. Because it's not a complete end value across the whole channel. We have asphalt on the bottom here, which has an end value of 0.011. We also have sand on the sides where it was cut out of the channel at a value of 0.015. So to do this, we're going to have to find a composite end, which is given by end side, which is going to be our sand times perimeter plus end bottom, which is also given by its perimeter, divided by the total perimeter. So, we're going to put in our end values. Now we already know the perimeter of the bottom, so that's going to be just 20 feet. The perimeters of the sides, which I neglected to mention last time, is actually going to be just a simplification version of the perimeter. So it's just going to be 2y. Actually, you want to do this with V2. Take the whole perimeter like we calculated and subtract the bottom. So we had 62.74, I think, or 72. Subtract out our 20. We're given. Okay, so that's just giving our perimeter of the sides. We're going to figure it out. So let's plug that in here. Divide that by our total perimeter, which is 62.72. So our composite n value, if you calculate all this out, you're going to get 0.0142. Cool. So now we have our Manning's n, we have our hydraulic radius. Erase this real quick, make sure you get that down. All right, now we're going to plug all this into our Manning's equation, which you might know already. So we're trying to find the velocity. So V, because we're in feet, we're in English units, we're going to have the 1.49 on the top over our Manning's. Then we're going to multiply by our hydraulic radius to the 2/3, so that's going to be 6. And then we're going to multiply by our slope, which is given up here 0.001. Very flat. And that's to the 1/2. All right, so remember, what we're trying to find in this problem is whether the sand on the sides of the thing is going to get scoured away. So to do that, we're going to have to figure out the velocity we have right now and compare it to the scour velocity, which we have as the scour for sand is 0.79. So that's supposed to be feet per second. So channel is going to scour when the velocity is greater than v scour. So we're going to calculate this out, this right here, to find our actual channel velocity as right now. And if you run all these numbers through, you're going to get a velocity of 3.53 feet per second. All right, so since we know our velocity is going to be greater than the scour velocity, we can safely say yes, the channel is going to be scoured away in the sides, thus solving our problem. Thank you.